All right, y'all. The first thing we're going to do today is practice finding derivatives on our calculator. So, you will have to find derivatives both by hand and by your calculator on the AP exam. So, please do not abuse this magic and this power that I'm about to teach you and only find derivatives on your calculator from now on. It's actually more accurate, most accurate, to find the derivative by hand, but you need to know this. So that's why I'm teaching it to you. All right, so here are the calculators. I'm using a TI-84 plus CE on my computer, and then here are the calculator like keystrokes or the things you need to do to find the derivative. I'm going to show you this, but like just so you know, this is in your OneNote. So you're going to start with math and then go to 8, and then we are going to enter our function following these steps. All right, and this is like what the derivative looks like in your calculator. So this ddx x squared at x equals -3. So really quick, I'm going to explain like what this is finding the derivative of. This would be like f of x equals x squared minus 5x plus 6. This example in the calculator, and this would be saying find f prime of -3. So you can see they plugged -3 in right here. They plugged their function in right here, and then it spat out the derivative. The answer is -11. Okay, so let's go ahead and do an example for practice. So use your calculator to find the derivative of f of x equals x squared minus 5x plus 6 at x equals -3. We are going to do this example together. So I'm going to my calculator. The first step you want to do is press math, the math button, and it'll take you here. And then if you scroll down, you'll see a thing that says in derive or in deriv. That means derivative. So you can press math and then 8. And it gets you here. Okay, we always take the derivative with respect to what variable? Derivative, well, not always, but most often the derivative with respect to x. So we're going to put an x there using the button that says xt theta n. Okay, and then we're going to put our equations. So let me go back to where it gives me that x squared minus 5x plus 6. Okay, so we're going to go x squared minus 5x plus 6. And then we're trying to find this derivative at x equals -3. So I'm going to press negative, and remember the negative sign is not the same as the minus sign, -3, and then press enter. And it gives us the answer, -11. Okay, it's easy. It's as easy as that. So that is how you find the derivative on a calculator. Now we are going to talk about the derivatives of special functions that you need to know. The derivatives of special functions that you need to know. And the first one we're going to talk about is the derivative of sine and cosine and then tangent. So get this down, derivatives of sine, cosine, and tangent. And let's start with sine and cosine. The first thing we're going to do is look at the derivative of sine on the calculator. And we're going to graph the derivative. Remember, anytime that you're using trig, you need to have your calculator in radians, and I'm going to show you how to make sure that's a thing. And then you're going to use zoom trig when you're graphing it. Okay, so here's the instructions on how to graph derivatives with your calculator. You just put the derivative that you're trying to graph in the y equals area of your calculator, and then you make x equal x. That's very important. X is going to equal x, not a number. We don't want the derivative at a specific number. We want to graph the whole thing. Okay, so let me go ahead and do this. We're trying to graph the derivative of sine just to see what we get. So I'm going to go to y equals, and then I'm going to go to math 8. That gives me the derivative. Derivative with respect to x goes there. I'm graphing the derivative of sine x, and then I need another parentheses to close that x off, at x equals x. Okay, before I graph this, let me make sure I'm in the right mode. I should be in radian mode anytime I'm using trig functions. So I'm going to click on mode, and do you see how radian is highlighted in black here? That means that I am in radian mode, So I'm good to go. I can press enter to make sure that that stays on radian mode. Okay, and now I'm going to go back to y equals, and we're ready to graph this thing. So if you're graphing trig functions, it often is helpful to use zoom and then trig. Do you see number 7 says z trig? So we're going to do zoom and then 7 or trig. And here we go. That is a graph of the derivative of sine. This is the graph of the derivative of sine. And I want to pose a question. Does this graph look familiar? What does this graph look like? Go ahead and tell me. All right, this graph should look familiar. This is the graph of cosine. It starts up at 1, right? And then it looks almost identical to sine. It starts up at 1 and it is a wave. So the graph of sine should look, or the graph of the derivative of sine should look familiar, because here we go. Are we ready to take some notes? The derivative of sine of x equals, the derivative of sine of x equals cosine of x. The derivative of sine is cosine. You could put cosine, I don't like to have it in parentheses. I don't know. I'm just going to put it like this. Cosine x. Okay. So now, what do we think? What could you guess the derivative of cosine is? Go ahead and guess. Tell me what you think the derivative of cosine might be. Go. All right, if you said sine, you are kind of right. The derivative of cosine is negative sine of x. All right, and then I want you to put like a little star, a note to yourself. This is really important. So note to self, the derivative of cos of, and we're going to write cos, like the things that have co in front of them, cosine, cotangent, cosecant. The derivative of cos are negative, always. So that's why the derivative of cosine is negative sine. Derivative of cos are negative. All right. Let's do the derivative of tangent now. So what is the derivative of tangent? The derivative of tangent is secant squared x. And I just want to give y'all a reminder. This is the same as writing secant of x squared. But in calculus and in higher level math, you don't usually write it this way. You write it this way, secant squared x. But that's the same thing. It just means you have two secants multiplying on each other. Okay, and again, as another reminder, this is also the same as secant x times secant x, right? Those are all equivalent forms, but this is the one that you use in higher level math. All right, that's the derivative of tangent. Now, let's learn the derivative of another, oh wait, just kidding. We have another special function coming up, but first let's do an example. Let's use the derivative, our knowledge of the derivative of cosine and sine to do this example. So, we are going to find f prime of x. Let's go ahead and start. Our rules of taking derivatives tell us that the constant needs to stay out in front, so 3 stays out in front, and then multiplies on whatever the derivative of your first term is. So what is the derivative of cosine? The derivative of cosine is negative sine, right? Because the derivatives of cos are negative. So we're going to say negative sine x. That's the derivative of cosine. And now we're going to put the negative 2, because that's a constant. It's going to stay out in front. Then we need to do the derivative of sine. So let's go ahead and do the derivative of sine x. That is cosine x, right? And then we need to take these derivatives. But before we can take these derivatives, I need to rewrite these. So before I take derivatives, I'm going to rewrite these in equivalent form. So I want you to tell me what is the fourth root of x cubed the same as? If I wanted to write that with an exponent, what would I write? All right, the fourth root of x cubed is x to the 3/4. All right, I have not taken a derivative yet. This is the original function, f of x, but I'm doing that so that I can use the power rule. So now I can take the derivative using the power rule. I will get, remember, power rule, take the 3/4 out in front and then subtract 1. So I get plus, and then 3/4 x to the 3/4 minus 1 is -1/4. And we will deal with writing that in like a multiple choice style in a second. And then this one always tricks students. This one always freaks students out. How can I rewrite this guy? Well, the way that I would rewrite this term is I would split the fraction. So we have, let's split this fraction. We'll split it into two fractions with a common denominator. So we'll make that 2 plus 2x cubed over 7, or x to the 7th, minus x to the 4th over x to the 7th. All right, cool. Now we can simplify these. So let me go up a little bit. I'm going to simplify these. X cubed over x to the 7th, that is the same as 2 times x to the -4. And then minus, remember, we haven't taken any derivatives yet. We're just rewriting the original function f of x so that we can take a derivative using the power rule. So now minus x to the 4th over x to the 7th. Remember, you subtract these. So you do 4 minus 7 to get your new exponent. That's -3. So we have x to the -3. And then I did 3 minus 7 here to get to the x to the -4th. Okay, now let's take derivatives of these. We like to see these. We can use the power rule on those. Okay, so we get plus, there was a plus here, so plus -8, because I'm doing -4 multiplied on the 2, and then x to the -4 minus 1, that's -5. And then we get -3 multiplying out on that negative sign gives me +3, x to the negative, remember we're subtracting 1 on these exponents, so -3 minus 1 is -4. Okay, this is a perfectly acceptable answer for a short answer. So let's go ahead and actually, really quick, I'm going to like highlight all these pieces so that you know the derivative of this piece. The derivative of that piece was this. The derivative of this piece was this -8x. And then the derivative of, lastly, we have this piece was this piece. Okay, so now let's simplify. For multiple choice. So for multiple choice, you will see it like this. F prime of x equals -3 sine x. I brought the negative off the sign in front. And then we have -2 cosine x. And then we have plus 3 over 4. That negative exponent on the x is going to bring it to the bottom. And then power 1/4, that is the same as 4th root. So that's 4th root of x. Then we have -8 over x to the 5th. Again, the negative exponent pushes that x to the bottom, and then the exponent turns positive. And lastly, we have +3 over x to the 4th. There we go. This is multiple choice. Short answer was first, and then multiple choice. That's how your answers can be represented. Okay, let's learn some more special derivatives that you need to know and have memorized. So the first one, fact. The derivative with respect to x of e to the x equals e to the x. And here's a fascinating fact, or a fun fact. E to the x is the only non-zero function that is its own derivative. So e to the x is the derivative of e to the x. It's itself. It's the only function that has this situation. All right, so that should be easy to remember. The derivative of e to the x is e to the x. You're supposed to know all of these special derivatives. Let's go into another one. All right, the derivative of a to the x. So this is similar to e to the x. We're going to start it similarly. So the derivative of a to the x is a to the x, but then we need to multiply times natural log of a. All right, so oftentimes you will see this written flipped. So because it's multiplication, we can write natural log of a times a to the x. You'll see it written that way. I think of it this way because I like to think of the derivative of a to the x is similar to e to the x in that it has the same like things show up in its derivative. Okay, so now let's go on to the example for this. So for example, the derivative, I'm on number 1, the derivative with respect to x of 2 to the x would be, copy the 2 to the x, 2 to the x, a is 2 here, right? A is 2, and then times natural log of 2. Sweet. I want you to do this one. You do this problem. What is the derivative of 1/3 to the x? Go. Derivative of 1/3 to the x is going to be 1/3 to the x times natural log of 1/3. All right, pretty easy, right? Okay, so that is another derivative that you need to know, the derivative of a to the x. And we have 2 more for you. This one's super important. The derivative of, what is the derivative with respect to x of natural log of x? That is 1 over x. The derivative of natural log of x is 1 over x. Got to know that. We're going to use it a ton. And then the last one I have for you is the derivative with respect to x of log base b of x. So this is similar to the natural log derivative. You're going to do 1 over x times natural log of your base, whatever your base was, b. 1 over x times natural log of b. So you can see that it has like the 1 over x, kind of similar to the natural log derivative, but then you divide by the natural log of b, and that's when you have a base that is something other than e, because the natural log base is e, right? Okay, and let's do one example of that derivative. So example, what is the derivative with respect to x of log base 5 of x? It would be 1 over x times natural log of 5. Done. That is that derivative. Okay, so you need to know all of these derivatives that we just went over, that we just covered. Please, I would suggest studying them. So please study them. Write them down in your notes. Make sure you have every single one of those derivatives in your notes, and then study them. We will do some like quizzes, derivative quizzes, where you will have to tell me what each derivative is. All right, that's it for today. Good work.